These are the 12.1 notes for trig. We're going to be talking about a new topic, vectors, today. So what is a vector? A vector is a line segment that has a magnitude, which just means the length, and a certain direction. So you can see this first kind of arrow here. This is your vector. How long it is called the magnitude, and the direction it's going, like 30 degrees, would be your direction. The starting point of this is called the tail, and then where the arrow is called the head of the vector. So we have three vectors here, each with a different magnitude and a different direction, A, B, and C. So which vector has the smallest magnitude? Which one is the shortest? That would be B. What about the largest magnitude? That would be A, is the longest one. Direction of 240. So the directions are a little bit easier to see if you think about them all starting from the same point. So if you looked at vector A and kind of moved that to there, and then you took B and put it on, it looks like that. And then C looks like it's going downhill like that. So direction of 240, C is the only one that could possibly be 240 degrees. And then a direction of 50, that would have to be vector A. So again, notice that the vectors are easier to read if we always start them on the origin 0, 0. When we do that, it's called component form. So the components of a vector are the x and y values of the terminal point, and the terminal point is the end of it. So if you think about it, it'd be this part right here of a vector when the initial point is at the origin. So initial point always at the origin, and you write it with these little kind of triangular parentheses, AB. So we're going to first start by drawing the vector at negative 2, 6. That's your initial point. And with a terminal point at 3, 2. And we'll just connect those. Make sure this one is the one that has the arrow on it. All right, so there's the vector. Now what we're going to do is we're going to move that vector so that way it ends up starting at 0, 0. A different color, green. All right, so we're going to move this to 0, 0. You're going to take the initial point, and it looks like in order to move it to there, you would have to move it to the right 2 and down 6. So we'll do that same thing with the next one. We'll move this dot right 2 and down 6. And then the entire vector just kind of shifts downward like that. So the pink and the purple vectors are the same. The purple is what's called component form. And then you just tell where it ends, which would be 5, negative 4. And we know that every time it comes in that format, it starts at 0, 0. So instead of having to give 2 pieces of information, we just have to give 1 piece of information. A little bit more helpful, a little bit more straightforward. All right, now the magnitude is just the length of this. So in order to find the magnitude, we'll kind of do what we did before with Pythagorean theorem. So this side and that side will be the A and the B. So A squared plus B squared equals C squared. That'll be 5 squared plus 4 squared equals C squared. 25 plus 16 is 41. And then we'll just square root that. If it's a decimal, just go ahead and leave it as the square root of whatever. So the length, meaning this edge right here, has a length of the square root of 41, which in your calculator ends up being about 6 point something. All right, on the back side, what do we do if we want to change it to a component form, but we don't have a graph to shift it? Here's what we'll do. We'll do the terminal point minus the initial point. And we could have done that on the front here, so let's go back a little bit. If we did the terminal point, 3, minus the initial point, negative 2, change that to a plus and gets us 5, that's that right there. And then if we do the y's, terminal point minus initial point, that gives us negative 4, and you can see that that's right there. So if you have a graph, you can shift it. If not, terminal minus initial. So for part A, Do the x's first, -1 minus -6. Do the y's next, 1 minus 3. And then just make sure you're carefully adding or subtracting those. It gets us 5 and -2. And then write it using the notation 5, -2, using those triangular brackets. The next one, same thing, 3 minus 1, and -2 minus -7. 2, double negative turns positive, 5, 2, comma, 5. And both of those, because they're in component form, means they started originally at 0, 0. All right, the magnitude. We've already talked about the magnitude. We use Pythagorean theorem, but they're introducing a slightly different formula. They just went ahead and square rooted it from the beginning, as opposed to waiting till the end and square rooting C. Also notice the notation here. It's like a double absolute value symbol. That just means magnitude. So anytime you see that, just note that they're asking you to find the magnitude. We're going to have to turn these into component form first, remember, because we only have an A and a B, and we have 4 numbers here. So we'll start by doing terminal minus initial, terminal minus initial. That gives us the component of 3, 2. And this can be our A and our B, and we can plug them in. 3 squared plus 2 squared is 9 plus 4, which is the square root of 13, meaning the length of that vector is the square root of 13. Just so you're aware, means it would start right here. It would end at the point 3, 2. And this length right here, that distance, would be the square root of 13, which ends up being 3 point something. All right, last one. Change it into component form first. -2 minus 4, 1 minus 9, -6, -8. And then just plug it into the magnitude equation, which again is just Pythagorean theorem. Going a little fast on this last part, I know, but if you need to, you can always slow the video down, just pause it, go back to the stuff that you need. Square root of 100 gives us a 10, which means the length of that vector would be 10. And that's it.